cover an interesting aspect of digital delay-based effects. The ability to freeze them, aka lossless 100% feedback delay loops. The prerequisites to implement the freeze functionality is rather simple. We need a single or multiple delays with an adjustable feedback with delay time roughly larger than 50 milliseconds. 50 milliseconds is exactly the wavelength of the lowest audible frequency, 20 Hz. If we freeze delays shorter than 50 milliseconds, we do granular synthesis, which is an interesting effect as well, but not what we want in this case. The simplest topology for a freezable delay-based effect is an input going through a gain stage G1, which determines how much of the input is fed into the delay stage, set to the power of -n. The delayed signal is tapped and sent through a gain stage G2 back to the input. The amplification of G2 determines the feedback. A virtual switch S1 allows to bypass the input signal, which is mixed with the delayed signal. I left out 2 more gain stages which allow to mix the delayed with the input signal for the sake of brevity. When the freeze is engaged, the feedback is quickly but not instantaneously ramped to 1, while the input gain is ramped to 0. Then the delay enters the frozen stage where the sample currently read is directly copied back to the delay buffer. When the freeze ends, here, the process is reversed. Let's skim briefly over the concrete implementation. The base class for all the audio effects contains a few methods related to the freeze functionality. The property declaring whether the effect supports the freeze functionality. This is used by the UI to react on a long press and also to display this nice snowflake I designed here. Then we have the method initiating the freeze and unfreeze/melt. And then the freeze stage, which can be either melted, freezing, frozen, and melting. 2 unfunctions called by the OS/system when the frozen state is entered or left. Another method indicating whether the effect is currently frozen. Just a side note, I added the mode where single effects program can be stepped through and switched on or off individually. Off in this case means no more input into the effect while still blending the direct with the effect signal, so we don't have cut off of delay or reverb tails, as quickly demonstrated here. The process sample function of the base class now handles the transitional states by increasing and decreasing a freeze counter and calling on freeze. Freeze and unfreeze set the state accordingly. Also unfreeze calls on melt if the state was frozen before. When transitioning into the frozen state, we essentially store the old feedback value into a buffer. The unfunction sets the frozen flag of the underlying audio processing function, which is called in the process sample function. In this function, the transitioning states are handled as explained before. Lastly, let's check what happens in the audio processing function itself. When the state is not frozen, the sample fed back is passed through a feedback function, if present, and is multiplied with a feedback value, then written back into the delay buffer. When frozen, the sample is written back directly. Now let's hear some sound samples without talking in between.